Now it's time to see how we can execute our code sequentially, concurrently, and lazily. And for that I'm gonna delete the supervisor scope because you don't need this. I'm gonna delete the handler because we also don't need this. Now, we already touched a little bit on this, on how to execute our code sequentially and how to execute our code concurrently in parallel. And to execute by default, the way we have the code now, this code is going to be executed. But first, let's go down here to see if I have an exception. Yeah, I have this exception, so let's delete this. So by default, the way we have our coroutines defined here, they're going to be executed in parallel. So by default, they are going to be started in parallel, and you saw that when you look at how much time it took to launch and finish their work. So if you run this code, those coroutines are going to be executed in parallel, as you saw in the last video. So you can see they start all at the same time, and you get result 2, result 3, result 1, parent job success, and you get total time 2 seconds, even though if you add the time of all of our suspending function is 6 seconds, but because they are started in parallel, so they start at the same time, it only took 2 seconds to execute all of them. Now if you want to execute them sequentially, so one after another, and in that case you're gonna have 6 seconds, you just type job1 dot join, and that means that wait for this coroutine to finish and then execute the next coroutine. And let's do the same thing for job 2. So job2 dot join. So what we are saying now is, first wait for the first coroutine to finish and then execute the second coroutine, and also wait for the second coroutine to finish and then execute the third coroutine. And now if you run this, pay attention at the total time that it took to execute all of them. So if you run our code, and if you look at the output, as you can see, it says fake work 1 starts, fake work 1 finish, result 1, fake work 2 starts, fake work 2 finish, fake work 3 starts, fake work 3 finish. So they are executed sequentially. So you get result 3, parent job success, and the total time is 6 seconds. So this is because now they are executed one after another. So one finishes, the next starts. The second finishes, the next one starts. So the total time, this is why the total time now is 6 seconds. So this is how you can execute the code sequentially. The next way of executing our coroutines is lazily. And lazily means that we're gonna execute our coroutines only if we use the result that the coroutines gave us back in the code. So let's delete this because you don't need this. And I'm gonna change the launch to async because it's gonna illustrate better how that is gonna work. So I'm gonna change this to async. So async. So this is just a different coroutine builder. We looked at this in our video was about coroutines builders. Async, also async. And I'm gonna delete this, because now this value is going to be returned in the variable job3. Also here, also here, because the function get data1 and get data2 and 3 return a value, and that value is going to be returned in those variables. So as you can see, we have variable first it's of type def first thing. I'm not going to type the type again because it can be inferred. Now I'm going to uncomment this code, and I'm gonna type job1.await, job2.await, and I'm gonna put back a plus, I'm gonna put quotation marks, /, and I'm gonna type job3 $sign actually, job3 dot await. And if you press Shift Control P, as you can see, this whole expression is of type string, so this is going to return the value that is going to be returned by those functions. So it's going to return result 1, result 2, and result 3. So we're going to get this back that we have here and here and here. Now if I go up, if I comment this code, let's say, and I don't use the result in my code, and I run this code, look what happens. So now I'm not using the result that the coroutines are given back in my code, but they are still executed. So as you can see here, they are still executed, and we get work 1 finish, work 2 finish, work 3 finish, and we get parent job success. But we don't use the results, so we don't use what those coroutines are giving back, their work. You don't use that in our code, so it doesn't make sense to have them executed. And in that case, you can have the coroutines starting lazily, and starting lazily just means that is gonna start the coroutine only if you use the result that coroutine gives back in your code. And to start a coroutine lazily, you put parentheses at the end of the async. So you put parentheses and you type star. So this is a name argument, start equals coroutine start, and we choose this one, coroutine start.lazy. And now that coroutine is going to be started lazily. It's not going to be started if you don't use the result in our code. Also here we're going to type the same, start equals coroutine coroutine start.lazy, and also here start equals coroutine start.lazy. Let's press Ctrl Alt L, and let's actually put this in a more concise way. So this is more concise. So if I put this like this and this, not this. All right, and let's put let's add the space here. Now, if I run this code, now you're not gonna see that the coroutines are started, because we're not using them. You're not using their result in our code. You only get main program starts, so we get main. Now the problem is that because we have here parent job.join, this never finishes. So let's comment this also. So comment with line comment, I don't see where it is. So let's run this again. So get main program starts, total time, and get main program ends. So now we don't get our coroutines started because we don't use them inside our code. But if you use them inside our code, so let's uncomment this. So let's go to code and let's comment with line comment. That is gonna undo. Now, if I use the result in our code, so if I type print line and job1 data-await, job2 data-await, and job3 data-await. Now, because I'm using them inside our code, I'm using the result that they are giving back. Now they're going to be started. So as you can see, now they're not grayed out. So now if I run this, we get main program start, get fake one start, fake 1 to finish, and so on. And then we get result 1, result 2, result 3, and parent job success, total time 6 seconds. So now our coroutines are started, because here on this line of code we are using the result that the suspending function are giving back to the variable that we define here, because you use them inside our code. Now they are started. But if you don't use them inside your code, they're not going to be started. They're going to be staying there and going to be started only when you use them in your code. So this is how you can use start a coroutine lazily. And now I'm going to end the video, and then the next video I'm going to talk a little bit more about coroutine scope.